Okay, let me share the screen. Just 1 minute. Yes, yes. So let me try to share it again. Yeah, let me see if it works. Okay, okay. Can you see my screen? All right, all right. So, hello everyone. My name is Plinio. I'm the lead UX designer of Kleros. So today we're going to talk about modular design, basically how it has influence on design systems. So, but before we get more deeper into the subject, I'd like to bring interesting curiosity for everyone. So let's imagine, for example, we have a simple brick like two by four bricks with 8 studs on top, and we have 6 pieces of it. So let's try to imagine how many combinations we can make with these 6 bricks. Well, the answer for this, of course, was not calculated by me. I'm just a designer, but some Danish mathematicians try to calculate that combinations, and the number is absolutely astronomical. Their calculation said you have to be possible to make 915,103,765 different combinations with just these 6 pieces. It's really interesting to note here how simple bricks like this can create some complex, sophisticated things. For example, just variating the combinations, and these calculations didn't consider different colors, just considering the same color. So you can have an idea how modularization can create some complex things. For the ones that are more interested in these calculations and the specifics of it, there's an interesting paper called The Legal Counting Problem by Soren Eilers from University of Copenhagen. There they explains a bit about the controversy, how they get to these numbers, how they calculate the variations. So if some of you are interested for that, it's a nice reading. But the point of modularization here is to note how one simple brick can create something very complex, very sophisticated, very useful for mankind. Like, for example, colorful dinosaurs. So, of course, it's a joke, but the point here is to mention the importance of specific modules, specific atoms, and how they can combine together to bond new things. Well, but what does it have to do with products? There's an interesting paper from MIT, from Professor Carl Ulrich, called Fundamentals of Product Modularity. In this paper, the professor explores and discusses about modularization, and also defines a few types of modularization, which are, I'm going to explain here, for example, the 6 main types of modularization. So we have, for example, component sharing modularity, when different products reuse the same modules. We have component swapping modularity, where we have the same products using different modules depending on the use case, depending on the user journey part of the process. We have sectional modularity, where the different modules combine itself to bond a new thing. We have bus modularity, where different modules get together using a common platform. We also have cut-to-fit modularity, where we have a single product or single platform, a single module, but this module is somehow adapted or adjusted to fit specific needs and specific purposes. And as long as that, you also have mixed modularity, which is basically when you have 2 different modules and we blend together to form a third one. Like the analogy for colors, for example, we have yellow and blue, mixing them together, you get green. So that are the main types of modularity explained in this paper by Professor Carl Ulrich. And it's interesting to note that from ancient times and a century ago or so, people from manufacturing have been using modularity for many reasons. One important thing to note is that how modularity can be beneficial to creating complex things. So here I'm going to give some examples in practice of these types of modularity. For example, here we have 2 different products. On the left, we have Lingo, which is a translation product made for Ethereum ecosystem. And on the right, we have Escrow. Both products allow a connection in our system with Kleros Arbitro. So in case there's a dispute between translator and the translation requester, the disputes are sent to Kleros. In case you have disputes on an escrow transaction, for example, the disputes are sent to Kleros to resolve it. So it's a perfect example of component sharing modularity. 2 different products, different audiences, different purposes, but sharing the same common components. In this case, the evidence modules, which are the modules that allow people to add evidence in case there's a disagreement on the contract or the disagreement on translation. As long as that, I also have here an example for content swapping modularity. This is another DApp called tokens. So here, as I mentioned, we have a single product, but this product makes use of different modules depending on the phase of the process you are, the phase of the user journey the user are in, for example. So as the user progresses through the products, there's some time where it needs to display to him some specific module, like the appeal module, or exchange for another modules as the progression happens. So that's an example for component swapping modularity. Here I have a cut-to-fit modularity example. So we have the same product, the same component, but this component is slightly changed to address a particular target or particular purpose, depending on the use case you have. or the target audience you are trying to address. So we have the same product, same module. This module is likely changed to display different information depending on the phase of the process, or display different combinations of, uh, of information that needs depending on the time. So let's talk a little bit about the benefits. Modularity can bring gains in speed and productivity. It can save the development effort and time. It can leverage quality. It can better respond to change in case of disruption. So all the benefits can make it more scalable, more flexible, more reusable, more testable. So we can ask ourselves, why not everyone using modularity then? So there's some drawbacks, of course. Everything has advantages and disadvantages. The advantages of using modular systems and modular products are much higher than disadvantages. But just to mention, the main disadvantage of using a modular system probably is the complexity in terms of creating it. As for example, if you create a system that's modular, you can basically rely on creating independent modules, independent components, but we also need to make sure they all bond together to form a concise system, a consistent system. So it's not so easy at the first moment. You can define specific rules, specific attributes since the beginning of the process, so you can achieve that result. But also, to make a good user experience, you need to rely on a shared meaning. So I would like to ask you to reflect a little bit on a few questions I have to you. So here we have two items, let's say. On the left, we have a component. Some people call it different names. So some people can call it maybe fish or switch or toggle. The component on the right, people can call it collapse, expansion panel, accordion. So what's the real name? What's the right? What's the wrong? Actually, there's no right or wrong here. You can see I put some examples of design systems and also some frameworks that call it different names, so we can compare. For example, the component on the left, Material Design System, Bootstrap Framework, Edge Design System, and IBM Carbon Design System call it different names. IBM Carbon Design System call it Toggle, Material Design System, Bootstrap and Edge Design System called Switch. For the component on the right, Anti-Design System call it Collapse, Material Design System call it Expansion Panel, and Bootstrap and IBM Carbon Design System call it Accordion. So there's discrepancies on how different teams and different design systems call and use these terminologies. But the point to mention, and the really important point to mention here, is there's no right or wrong. The point is that the important point to highlight is that within your own team, you need to create a shared system. So the important is not if you are calling it different names. Some people use it more descriptive names. Some people use more contextual names. But what a tip I give is, for example, try to use the same names, the same terminology, the same ontology for your components within your own team. At least this, if you can create a shared meaning, a shared system where your developers, your designers, your team members all can adopt a similar terminology. It can save a lot of time in the future when the products and the systems start to scale. So that's the main point to mention regarding this. And there's a few things that I call essential things to create any design system. So I'll start talking about them now. One of them is creating a consistent visual language and a patterns library. So talking a little bit in continuation of the previous topic, uh, defining the components you are using, defining the terminology, the ontology you are using. So we have structured all the components, all the atoms, organisms, all the elements you are using in your design system is important from the beginning. So we have a structured uh, system to rely on. Also important and vital, can call the DNA or the core of any design system are the principles, the personality of your design system. So thinking in advance about what the principles, what the branding needs to communicate, what the personality of your design system, how you can communicate that to the users is important to create that strong structure so you can continue creating and developing your system. Also, extremely important is the definition of the typeface and timescale. Here's just an example of Kleros Design System. So we kind of decided to use a very narrow range in terms of type scale, but at the same time create a variation that facilitates our usage and creates something that we can use for different applications, but without creating some excessive number of type scales, typefaces. So it's easier to use, it's easier to communicate, both designers, developers, so everyone can rely and follow quite easily. So another point, extremely important in these 5 structural core things from design systems and modular design are defining a spacing scale. So we also decided here to define a spacing scale based on the 8 pixels units, which facilitates the communication as well. So we have a number of different spacings that I use for sizing icons, sizing components, paddings, margins, all spacings from all the products we are constructing basing on our design system rely on this spacing system. So it's easy for everyone, for designers to create a new product, a new module, for developers to rely on the specific spacing paddings and margins. So we don't need to guess what this padding is, what this margin is, or create some aleatory things like 71, 11 pixels or something. You basically rely on multiples of 8. So 8, 16, 24, 32, 48, 64. So it's easier to manage that. Also, on the structural point of the design system, modular design, rely on a grid. In this case, we use a 2x fluid 24 grid. So basically to structure our design to a responsive framework. And color. We have defined since the beginning, but with some adaptations through the process as we advance, very strong color schemes. So our branding calls for purple at the core, blue on the tails. So we have this strong purple focus. And what we create here, apart from a simple color scheme, is create a pair of colors. So we have, for example, a primary purple, and it has a version for light mode, a version for dark mode. And all the colors have this pairing, so it's easier to identify how you can switch from a product using a dark mode or light mode without much hassle. So it's also an important thing for this essentials, this core, this DNA part of structural things of design system modular design. Now, I'm going to enter something very interesting, which is the atomic methodology. Atomic methodology is a methodology for creating design systems and documenting it, created by Brad Frost. It's basically an analogy with chemistry. So Brad thought about the idea that both solids, liquids, gas, complex things, simple things, all rely on atoms. All are created by atoms. So we have atoms that bond together to form molecules that combine together to form organisms, and then move until we get to the pages, to more complex things. So that's the analogy used by Brad Frost for atomic methodology, and the same can be used for products, for example, where we have our components that bond together to form more complex components, more complex organisms, until we get the pages, the products, and ecosystems. So that's the main idea. Bringing together the analogy of our dinosaurs, pages are our dinosaurs here. So from simple things to the most complex things, all can be created following this structure. And the idea is quite simple. So I bring some examples. Here are some examples of atoms. So we have the most simple components that can work alone. For example, we have the search bar. We have drop-down selectors, buttons like primary button, a secondary button, tooltips, tabs, radio, checkboxes, switches, cards. So these are good examples of atoms in this atomic methodologies purpose. And for example, when atoms start to combine together, like we have here, the drop-down selector, the search bar, and a button, so we start creating molecules. And when this creates some more strong bonds and creates more complex things, we have our organisms. So this is an example of a module for token selection that we have. So here you can see different atoms combining together to form a module. We have the cards, we have the tabs on the top, the search bar, the selection. We have the secondary button on the left to return, the primary button on the right to move forward. And that's a perfect example of organism. And that's quite simple, straightforward methodology. It's extremely useful in terms of constructing a system, constructing a design system that many products can rely on. And from that one, have also templates, which are basically the structure and the script for how you create a product, final product, and you have a dinosaur. The final product, the final page or screen, we combine all these atoms, molecules, and organisms to form something that has some meaning for the user. So that's basically the idea of the atomic methodology. I try to explain it more simple way possible. And for that, I also want to share with you guys the Kleros Design System. I have published a public version of it if you guys want to take a look on Figma community. So there's a public file there that if you want to check it out, the structure, how you create our components, how you organize them into atoms, molecules, organisms, templates, and pages, how we bond everything together to create this language, this concise design system. Feel free to take a look on the link on the bottom. It's a file that's open. It's basically use the different components we have in different products from Kleros, Kleros Court, Lingo, tokens, dispute resolver, and so on. So If you're interested to look, feel free to look. You can duplicate the file, remix it, modify, and play a little bit with that. I hope it's some kind of source of inspiration for every team to start creating your own design systems. And before we conclude, I want to recommend some more design systems for inspiration. Basically, sorry, we have IBM Carbon design system. It's quite interesting, complex, and complete design system. If we want to take a look, for example, how they structure the components, the visual language, the styles, the guiding, the pattern libraries, it's quite interesting source of inspiration. GitHub Primer is also a very interesting design system to take a look. Shopify Polaris is very complete, especially in terms of user experience. It has a different approach from the rest of the design systems, bringing some more contextual things and in terms of how to use, how to adapt and combine the components. Material design system, I think everyone know or have heard about it. Apple Human Interfaces Guidelines, which is a very complete design system in terms of guidelines and some ideas in structuring the things, and Atlassian design system as well. So just some recommendations, some things I think it's interesting to look in if you are more interested in design systems. So that's it for my side. So thank you very much. Yeah, that's a good question. Actually, I see the ecosystem is improving a lot in this sense, for example. But I think what have to be done is mostly uh, evolve the idea that creating systems, taking systems instead of taking pages, let's say. So in terms of UX, things are outbound together into different ways, different accents and different perspectives. So it's important to try to spread the word for the ecosystem in terms of trying to think more in terms of systems, in terms of uh, complex things, rather than just creating a simple page or a simple screen. And this makes a huge difference in terms of user experience because a very interesting and important point of user experience are consistency. And consistency is only achieved by a strong and consistent system, a consistent and concise team. So I think the ecosystem probably will keep evolving. It takes time, I think, for everyone to to see that, but I'm very positive. I think everyone is already knowing and understanding the importance of UX and how the UX is not just the final layer, it's not just the visual thing, it's also part of how it works and how it behaves, how people react to the product. So I think I'm very positive the ecosystem will keep evolving very fast. Yeah. I think the main points of how to better address the users is trying to understand better the users. So making some user research and also trying to understand what's the reason behind users' behavior, trying to better, let's say, capture what's the real intention of the user when using your products. So I think it's a matter of trying to get deeper into research, especially user research and market research, so we can understand the product's perspective from the point of view of the user. And to adapt that, basically, you have to understand what the user really wants. It's not necessarily what he says he wants, but through proper research, you can identify what the user really wants to achieve using your product. So that make a huge difference in creating and adapting your product to address these intentions. Thank you.